The feeder cable for service entrance cable, often called SER cable, that runs from a main disconnect or sub-pole in a residential installation with a 200 amp service must be protected in a basement. The 2020 National Electrical Code, (ONEC), provides specific guidelines for the protection of these feeder cables to ensure safety and prevent electrical hazard. The primary means of protection is through the use of an overcurrent device. This device, which can be a circuit breaker or a fuse, must be located at the main service panel. Its purpose is to interrupt the flow of electricity if the current exceeds the safe ampacity of the feeder cable. This prevents overheating and potential fires. The overcurrent device must be rated for the ampacity of the feeder cable. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. Selecting the correct overcurrent device rating is crucial for effective protection. If the overcurrent device is rated too high, it may not trip or blow in time to prevent damage to the cable. If it's rated too low, it may nuisance trip, interrupting power unnecessarily. Accessibility of the overcurrent device is another important requirement. The NEC mandates that the overcurrent device must be readily accessible. This means it should be located where it can be easily reached and operated without requiring the use of tools or climbing over obstacles. This is essential for quick access in case of an emergency or for routine maintenance. In the basement environment, the feeder cable can be protected by either a circuit breaker or a fuse. Both devices serve the same purpose of interrupting the current in an overcurrent situation, but they operate differently. A circuit breaker is a resettable device that trips open when the current exceeds its rating. It can be manually reset after the fault is cleared. A fuse, on the other hand, is a one-time device that melts and breaks the circuit when the current exceeds its rating. Once a fuse blows, it must be replaced. When choosing between a circuit breaker and a fuse, several factors should be considered, including cost, ease of replacement, and the specific requirements of the installation. Circuit breakers are generally more expensive than fuses, but they offer the convenience of being resettable. Fuses are less expensive, but they require replacement after each overcurrent event. In addition to overcurrent protection, the NEC also addresses the physical protection of feeder cables. In a basement environment, cables are often exposed to potential damage from moisture, rodents, and physical impact. Therefore, it's important to protect the cable using appropriate methods such as running it through conduit or using cable trays. Conduit provides a rigid protective barrier against physical damage and moisture. It's available in various materials, including metal and plastic, and in different sizes to accommodate different cable sizes. Cable trays offer a more flexible solution for supporting and protecting cables, especially in long runs. They are typically made of metal and provide a ventilated pathway for the cables. When installing feeder cables in a basement, it's also important to ensure proper grounding. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the overcurrent device and prevent electrical shock hazards. The grounding system must be properly bonded to the metal enclosures and equipment to ensure effective grounding. Furthermore, it's important to comply with all applicable local codes and regulations. Local codes may have additional requirements or restrictions that are not covered by the NEC. It's always a good practice to consult with a qualified electrician or electrical inspector to ensure that the installation meets all applicable requirements. In summary, protecting SER cable feeders in a residential basement involves several key steps. Firstly, ensure that the feeder cable is protected by an overcurrent device located at the main service panel. Secondly, select an overcurrent device that is rated for the ampacity of the feeder cable. Thirdly, ensure that the overcurrent device is readily accessible. Fourthly, protect the cable from physical damage and moisture using appropriate methods such as conduit or cable trays. Fifthly, ensure proper grounding of the electrical system. And finally, comply with all applicable local codes and regulations. By following these guidelines, homeowners and electricians can ensure the safe and compliant installation of SER cable feeders in residential basements.